So normally when we talk about singularity in mathematics, it just means a point where something is undefined. A typical example is the function 1 over x, 1 divided by x. If you try to draw a graph of it, as you approach 0, things get higher and higher. 1 over a tenth is 10, 1 over a hundredth is 100, and so on. So it goes off to infinity. But on the negative side, it goes down to a negative infinity. So what's happening here at 0 is undefined. That's a mathematical singularity. When people talk about the technological singularity, they usually mean several different things, and they tend to get really confused. So one way of thinking about it is just technological growth getting faster and faster and faster. It's speeding off. So this is typically drawn as an exponential curve. And this is what the enthusiasts of technology like Ray Kurzweil are talking about. If you plot it on a logarithmic paper, it becomes a straight line and it looks very, very scientific. And we are indeed seeing an acceleration of a lot of technologies, but maybe it's not that fast, and maybe eventually it levels off. We don't know in many cases. However, there are also arguments that technology allows us to make better technology. So we have a feedback loop. We have our own ability to make technology. And technology feeds back in that ability to speed it up. And in that case, this growth might become faster. So instead of just going up exponentially, it takes off. And that indeed has a finite time singularity. There is a point where progress becomes infinite in the model. At this point, many people say, no way, that can't happen in the real physical universe. There's always going to be some kind of upper limit that you slam into, which might be true, but that limit could be extremely high. And even if things level off and we get some calm time afterwards, this historical era might be extremely short. If it turns out to be that technology, self-improving artificial intelligence, reaches this in just a few months, well, human institutions are not going to be able to keep up. And even if we say, oh, maybe it's going to take 1,000 years, then you're going to have a transition from humans as hunter-gatherers to a brief period of agriculture to an even briefer period of industrialism, and then you have a total transformation and then the rest of history. We are kind of living right here at the inflection point where things are changing the fastest. Of course, others say what's important here is that we cannot say very much about what comes afterwards. We're going to be talking about a world that has very advanced technology, perhaps superintelligence, which means that whatever is being planned there, whatever is going on, is going to be beyond us. We can't say anything about this post-singularity world. So they are talking about the singularity as a kind of horizon of predictability. Yet there are many other interesting ideas. So one aspect is organization. So right now we're organized into small human groups, organized in bigger groups, and as we invent better ways of coordinating our endeavors, we become more powerful. Hunter-gatherers couldn't have built pyramids, simply because there are not enough of them, and no chieftain could get enough people under so long time to build a giant pyramid. A pharaoh could. But today, if the Chinese government decided they wanted 10,000 pyramids, they could set enormous industrial corporations in motion and implement it, because we have much better forms of organization. Now imagine in future as we can organize even better. An outsider would say, humans are almost looking like we got group minds. We organize ourselves into these giant pyramids of corporations, nations, online network and whatnot. And it's getting cheaper and cheaper to coordinate many, many people, which means that our brain power can be focused on a problem that needs to be solved, which essentially gives humanity as a whole a kind of superpower. So maybe the singularity might mean that we create a global mind in a sense that we're networked, connected, and very well coordinated. It might happen just because Facebook and Google allow us individually to work together, or maybe we actually started adding direct brain-to-brain links. It might not even matter if we have brain-to-brain links if we have good enough organizations. So accelerating technological growth is partially driven because there is more people around. More people means more minds that can be put onto solving problems. And also because we're getting better at solving problems. We have learning curves in the industry. As we build stuff, we become better at making it cheaply, and hence more people are buying it. More people are buying stuff, that means you can make more money making it, and so on. So things accelerate. And this might of course level off if we stop buying things, or if humanity doesn't continue having an explosion of population. But if you have self-improvement, then you can get an intelligence explosion. So the typical idea is something like that we have an optimization power that is being applied to itself. Sometimes we are also pushing by our own intelligence and our investment. Now the question is, this box, how well can it improve itself? For example, we have optimizing compilers. They take a piece of software and they try to find ways of making it running faster. You can run an optimizing compiler on itself, but it doesn't become enormously much better. It doesn't change what it's actually doing, it just becomes slightly faster, and next time you run it, well, it has already done what it can to improve speed, so it doesn't do anything more. But you can imagine something that actually rewrites its own code. Inside the box is the source code of how it works, and it might actually figure out a better way of doing that. And either changing that directly, or more likely, creating a new system that is even better at doing this improvement. And that system can of course be used to improve itself too. And that leads to other systems that are even better at improving themselves. At some point, the humans become relatively irrelevant here. Of course, a human might even be part of this system if we're thinking about an organization or maybe a cyborg. But quite often I think that the human brain is too messy to be easy to optimize. When you think about computer code, it's typically rather nicely structured. It's intended to be understandable by an intelligence, while the human brain, it's just intended to move us around in the world. It's messy, it's glorious, but it's also very hard to debug. So the problem might be that we're going to be outrun by systems that are very unlike ourselves, simply because they're easier to upgrade.